Cool. So yeah, some of us are here. Guess more students will join, but we can start. Let me share my screen. Okay, can you guys see my screen?
Yes, sir.
Yes.
Okay, cool. So here is the agenda I've been thinking about. Like we'll start with the, I think you might already know, like truth table of different Boolean operators like not, and or. Um, then we'll study like equal versus equal to, and some tidbit about how to avoid confusion between them and avoid typos. Then we'll look at short circuiting, nested ifs, and switch case. So feel free to, like, since this is a help session and not a lecture, like this will be a lot more interactive. So feel free to interrupt me at any time and let me know if something is confusing. So let's start with truth table. Um, so let's say we have, actually I can, let's just copy the whole thing.
Sir, please increase the font size.
Okay, is this better?
Yes, thank you.
Yeah. So, um, so like this is a program. I'll walk through it. So basically, what this is doing is, we are printing the truth table of different operators. So let's first look at the not operator. So this is going to say not true. What is not true? So actually, let's start even basic. Um, right. So, so we will first print what is not of 0, and let's run this. What is going on? Okay, so this is printing not of 0 is 1, and we can print what is not of 1. So not of 1 is 0. So what we can do is, so in C, like C doesn't have true and false as different like keywords. Like C99 had it, but this C doesn't. So what we can do is we can actually use this hash define, which is what is called like a pre-processing directive. So what it does is whenever it sees true, whenever it sees 1, it changes it to true. So we can change this code to say uh, not of true. So instead of 1, we are writing true, and instead of 0, we are writing false, just to like get a better formatted truth table. So now this is showing not of true is 0 and not of false is 1. And so it is still like printing not of true as 0, right? So we want to print it as false. So what we can do is, instead of this, we can use this tertiary operator that you learned on Monday, I think. So we can say yeah. So what this is saying is so like if this thing is true, whatever is in here, then print true, otherwise print false. So now since this is a string, we need to change %d to %s, and let's see what happens. So now this is printing it the way we want to print, like not of true is false and not of false is true. So this is our truth table for not operator. Any questions on this? Like we looked at many things here. So we looked at like hash define, which is a pre-processing directive. So what this is doing is wherever it sees true in the program, it replaces true with 1. Whenever it sees false, it replaces false with 0.
Sir, sir, please explain this line with ternary operator.
Okay, yeah.
How this is working?
Yeah, so ternary operator is similar to basically if else. So you must have seen if else. So like we had if true. So basically what this expression is doing, let's say we have a like if true, printf true, else printf false, right? So this is one way to write a if condition, right? So in the if condition, we give it the condition, then we print something, else we print something else. So this is a like a short form notation of the same thing. So what you can, so this program here is equivalent to printf %s true, true, false. So this is just a short form expression of writing if condition. So this program is equivalent to this program. So what this is doing is if it is true, then we will print true. If the condition is false, we will print false, right? So this operator works in the same way. What this is saying is whatever is before this question mark is true, then we will give this as the value. Otherwise, we will give this as the value.
Sir, where percentage S is used?
Yeah. So percentage S is for printing strings. So you could have used it like this. So you know percentage D is for printing integers, right? Like decimal. So similarly, %s is for printing any string. So this true is a string. So that's why we are using %s.
Sir, can we nest this statement like we nest if else? Can we nest this question mark and this colon also?
Yeah, let's look at that in the nesting. So nested question mark and colon. Yeah, we will get to this.
Okay, sir.
Yeah. So for now, like, is this program clear to you guys?
Sir, how did we use question mark and colon?
Yeah. So here we are saying. So previously, when we were not doing this, like, let me revert. So previously, when we were not doing this, and let me comment these two out. So previously, when we were not using question mark, we were seeing not of true is 0, not of false is 1, which is correct. But we want to see something like this, that not of true is false and not of false is true, right? So just to make the printing a little bit prettier, what we are doing is So this is a way to print like Boolean expression. So what we are saying is whatever is in here, if this is true, then we will print true. If whatever is in here is false, then we will print false. So we change this not of true into this tertiary operator. Similarly, we change this not of false into this tertiary operator. So now if I run this, like it is showing me that not of true is false and not of false is true. So let's keep moving on. So this was the not operator. Then let's look at the truth table for and. So what this is saying, this is just doing what is true and true, true and false, false and true, and false and false, right? So if I run this, it shows me that true and true is true, true and false is false, false and true is false, false and false is false. So this is a revision of logical operators. I hope this is not surprising.
Look, it seems.
Sir,
Yeah.
sir, is it necessary to use both the statement? Means it is necessary to use this colon in this ternary operator, like in if else statement. If we can use only if without else also. So
Yeah.
here can be used that without
It's a good.
ternary operator.
That's a good. And so in this case, it is actually necessary. So we can try it, and I'll tell you the reason in a bit. But let's try it first. If we basically skip this false, right? I think that is what you're saying. And if I run this, this is saying, okay, I'm expecting an expression. Let's try to remove this colon as well. And now this is expecting a colon, like this is confused. So basically the reason for this is this whole thing is evaluating to a value, right? So %s, for example, in this case, needs a value from this expression, right? So if you skip the false part, then we don't know what to do here, right? So this whole thing is evaluating to an expression, to a value. So this is a little bit different than your if else. So, but you can do the same thing in if else. So let's say you could be writing something like this as a program. So what this is saying is like if the if the condition here is true, then x has a value of 0, otherwise x has a value of 1. So this whole thing is evaluating to a value, which goes into whatever is on the left hand side. So in this case, this whole value is going into %s. That's how it is printing, right?
Excuse me, sir.
Yeah.
Sir, we have not yet been taught about strings, so I cannot understand properly about the strings used.
Yeah, so it's not, yeah, for our purpose, like, don't worry about it too much. Like, I think you will learn about internals of the string, like how they work and stuff. But for our purpose, you can imagine, so anything you put in double quotes, like whatever you write here, this entire thing is called a string. So this can be, I think you have been writing it, right? So when you wrote like printf input width, length, and breadth of cuboid, right? You wrote something like this in your question, in your assignment. So this is, anytime you write something in double quotes is a string. So when you want to print a string, you put a %s. So that is all you need to know right now. You will learn more about it in detail in following lectures. But for now, like whatever you put in double quotes is a string, right? So
Sir?
yeah.
So for percentage as like in the true or false, we have to write in the string. That
Right.
is after the comma we have to write in string.
Right.
And sir, why then true are not in string? Yes, they.
So
Yeah,
this is a string, right?
this is in string, but before question mark they are not in a string, that is true.
Yeah, so recall again, like this is equivalent to this program, right? So basically, whatever is in if is a conditional expression, right? So similarly here, whatever is before question mark is a conditional expression. So this is a true or false, like this evaluates to an integer value. But outside of question mark is a string. So this is a string and this is a string, right? So this makes sense. Let's go ahead and print our entire truth table for all the operators. Okay, so this is saying not of true is false, not of false is true, true and true is true, true and false is false, false and true is false, false and false is false. For or true is true, true or false is true, false or true is true, and false or false is false. So I hope this is clear, and I hope you agree with this truth table. Yeah, like this is how the logical operators work, right? The not, and or. That's how they work. So let's move on.
Sir, if we doesn't give command that slash define true is 1 and slash define false is 0, then it will work or not?
Let's try it. Let's try it. So it does not work because it is saying use of undeclared identifier false, right? So this is similar to like writing like random stuff here, right? Like I'm writing Abhilash. So I never defined what is Abhilash, so it doesn't know what to do with this, right? So this is not a pre-declared value here. So that's why it doesn't know what is true. Like you need to tell it what is true.
So we can define any string there to be anything.
Yep, that is another good question. So let's turn true to what do you want to call it? Let's say small true, or even we can go even more hyperbolic. So let's call it like call 100. So you can put anything basically. So just that the readability is now gone, like it is hard to understand, but the code will work now because the compiler is just taking your word for it. It is just replacing call 100 with the 1.
Sir,
Yeah.
what is the command for selecting all the words of same type? Like you are selecting true and then replacing all at once.
That is the same question. So let's
Hello. So am I
Sir, you
audible?
are not audible.
yeah, can you hear me now?
Yes, sir.
Yeah, can you see these JJKK things?
No, sir.
In key. Okay, interesting. Okay, don't worry about that then. So basically, to replace, we press colon. You can see like it went to colon. Then we do %s. This is saying search, and we are saying search for true, and replace it with call 100, and do it globally. So globally is do it in the whole file. So we are saying search for true, replace it with call 100 in the whole file. And when I press enter, this will change true to call 100 everywhere, right? And if I press U, which is undo, then we come back from call 100 to true.
So can we do the substitution in selective lines?
Yeah, we can. So in that case, what I generally do is just search for, so search is using slash, then do true and press enter. and let's say I only want to change it here. So you can see my cursor. This is here in true. So I just go ahead and change this one, right? So you
Then
just,
we can like we cannot directly do it through the search feature. Like we have to manually change it, right? For selective lines.
for selective lines, so another approach is you can select everywhere you want to change, and then let's try it. Actually, I don't do this much, but I think then if I press %s true call 100 and G, okay, that did not work. Yeah, there is some way to do it. I do not know it.
Sir, do we have to select true, or directly we can write this command to replace all letters?
You can write it directly. So if you want to, let's say, replace false by call 100, I'm just directly writing it. So
Sir,
the reason
in
it
which
is
mode we are doing this? Visual or in input?
this is normal mode. So after pressing escape a bunch of times, I just directly write it. So when I press colon, it goes into command mode, right? So I press colon and then do it. So you can see what I'm typing here, right? Down.
Yes, sir.
Yeah.
Yes, sir.
Okay, cool. So let's move on.
So we could have just one thing in like we have written printf true and false, and then in that we have written true and if true and false, then true other like that. If we wrote the same code as in the above line, like if we had written in the second line true and true question mark true colon false, would it have worked? Because
Wait, where?
this the whole condition that we have given in this line, the same condition we give in the second line.
If we give the same condition.
Yeah.
Yeah, it would work, but it will be confusing output. So you are saying like change true and false to true, right?
Yeah.
So let's run this. So now this is confusing us, right? This is saying true and false is equal to true. Like
so that means it does not work. That's what I was asking.
I mean, it is just going to print what you ask it to print.
Okay.
So yeah. Okay, cool. So let's move on to the next thing. Okay, equal to versus equal to. So equality.c, and let's copy some stuff from here. Okay, can someone tell me what this program will print? Hello.
So both lines.
Both the lines will print, and the value of I would be what here?
First it would be 3. Secondly it would be 4.
Okay. Cool. So let's run this. Yeah, these are warnings. We can ignore those. So this is exactly, you were right. Like first if I is equal to 3, second if I is equal to 4. Okay, what if I change this to I equal to 0? Then what will happen?
So second statement.
Only first line will be printed.
Second line will not be printed, right?
Yeah.
Okay.
So second line will still be printed. Oh.
Okay, second line was not printed. So why do you think second line will be printed?
So because the assignment is it's also happening there. So since the second one is the assignment operator, it would always be true.
No, yeah. So yeah, actually that is incorrect understanding. So the value of this as an expression I equal to 0 will be 0.
The left hand expression, right? So
Yeah.
sorry, right hand, the
Right hand
numeral is the
the value. So this whole thing is interpreted as if 0, and since if 0 is false, like if 0, so we will not go inside this. So another quick note is like this is just for like teaching purpose. Like you shouldn't be writing such code because generally speaking this is confusing. Like if you want to write this code, you should write it as separate the assignment with equality. So you should write it as I equals 0 and then put I equals 0. So generally speaking, like this is typically a bad practice. Like you don't want to put assignment and if in the same statement. It's just generally confusing for a lot of people, and you actually will never see it in production code.
Sir, why was the second line printed when I was equal to 4?
So when I was equal to 4, this whole thing is evaluated to 4. And inside if anything is, if you give it a non-zero integer, then it goes inside the printf. So since inside if we are giving it a 4, this will go inside printf.
Sir, if right we in the int, if we assign I equals to 0, then none of the statement will be executed or printed.
Inside if, yeah. So before all this, I does not have a value of 0, right? So before this, I has a value of 3. And this if is true. When I is 3, this is true, right? So this will still be printed. But after you set I to 0, and since if is evaluating to 0, this statement will not be printed.
Sir, I am saying if we print in int I equals to 3, if we replace by 0.
Okay. Yeah, you are right. So in this case, this will be false, and then this will also be false. So we can try it, and nothing is printed. Cool. So looks like you folks understand this. So yeah,
Sir, in the case before when I was equal to 3, in the second case, we wrote if I equal to 4, and it was the output. So why this happened? The same is not happening for I equals 0.
So for I equals 0, like if I put I equals 4 here, then it will print the second line. I is equal to 3. What did I do? I didn't save the file. Let's run it again. So yeah, second one is printed. So basically this is checking whether I is 3 or not, but since I is 0, this is false, so this is not printed. This is putting value of 4 inside I, and it is also saying if 4. So if 4 will be true, so it will come inside and print the second line. So it will only print the second line in this case.
So when int I equals 3, it was int I equals 3, and in the second part it was I equal to 0. In that case, we only had output at the first line.
Correct.
So why was the second line not the output?
Okay, I feel like I've explained it multiple times. So like this thing is always, so no matter what is inside I, like we don't even care about this. Let's focus on one thing at a time. Okay, so let's start with this code, right? So basically in this code, nothing will be printed. Let's try it out, save it and run it. So nothing is printed, right? So what is going on is it is putting the value 0 inside I. So that is 1. So what is this if expression doing? So this is saying assign 0 to I. This is first thing it is doing. Second, it is saying evaluate it as if 0. So if 0, since 0 is interpreted as false, so if so it will not go inside the if. in the if block. So this printf is not going to be printed, right? And if I change it to 4, then in that case, this is saying assign 4 to I and evaluate this line as if 4. So since if 4 is true, it will go in this print. Cool. So let's keep moving on. Yeah.
So if I equal to 0 and we know that second line, the line will not be evaluated because if 0 is there, but will 0 be assigned to I?
Yes. So we can try that out. So let's say this is saying outside if, and let's say this is 0, right? So basically I should be printed as 0 here, right? So we can make it more concrete by initially assigning it a value of 3. And if I run it, so I was indeed assigned to 0, but it did not go inside the if. So basically it will first assign the value to I and then evaluate it as if 0. Cool. So this makes sense now. Let us, so yeah, like as I was saying, like since this if is doing two things, it is generally very confusing to a lot of people. So you are not the only one. So that's why like it's recommended practice. If you do want to write such a code, write it like this, right? So separate out the two things. So put the assignment first and then the equality later. So it just makes the code easier to understand. And that's why you can see like compiler is actually giving us warning as well. Like it doesn't like putting assignment operators in if. But we are teaching it for teaching purpose. So we will use it in a bit to tell you like some interesting things about logical operators. So another good practice is like what you can do is, so sometimes what happens is you really wanted to use equal to, but during coding you somehow missed putting the second equal to, right? So in that case, like there will be an error in your code. So generally what people do is they basically flip these operators like 3 and I. So what you can do is 0 equal to I. So in this case, if you miss a equal to, this is now actually an invalid statement completely. So the compiler will give an error. So it is saying that 0 equal to I is invalid. But if I put 0 equal to I, then it is happy and moving on. So this is just a good practice to avoid errors. But I think, yeah. So is this clear? Like why? Like, are there any questions here? Okay, cool. So let's keep moving.
Sir, as we continue assigning the value of I in the if condition, that is I equal to 3, then the print continuously the value of the I is changing outside the if statement also.
Where here I equals 0?
Yeah, I equal to 0. Then outside the if body, if we print out what is the value of I, then it will be 0.
Yeah.
Okay.
Sir, like here we have an if statement, we have assigned value of I to be 0. So it means it is now evaluating if 0 means this will be false also, right?
Right.
Yeah.
Okay, cool. So looks like we are good on this. So now let's look at short circuiting. Yeah. So let's look at short circuiting. Okay, let's look at this code. So what this is saying is I equals 3, j equals 3. If I is not equal to 3 and j equals 4, then I will print inside if, and then I will print the value of both I and j. So what do you think will be the output in this program?
3 and 3.
3 and 3. Okay, very interesting. Someone is ahead of me. So that is very interesting. Why is it 3 and 3?
Sir, first statement is false, so it won't go to the second condition. It won't check the second. It won't assign j equal to 4.
Okay, awesome. Very awesome. So yeah, like what you just described is basically called short circuiting. So let's go back and look at our truth table. Yeah, or I can print it again. Okay, and then I can so basically the comment is saying that so since the first condition is false, like we know already that the output will be false, so we don't even need to worry about what is in the second expression to figure out like what is the overall output. So since we are already seeing false, we can just conclude that the whole thing will be false. So that is the short circuiting. So basically, since we know that this I not equal to 3 is false, right? Since I is equal to 3, we know that I not equal to 3 is already false. So now we don't need to evaluate this. We know this entire if condition will be false. So since we don't evaluate this, we will just so j will still have the value of 3 since we did not evaluate j equal to 4. And we can again look at the output. So if I run this, both I and j are equal to 3. But let's say if I switch these two conditions, right? So now what will happen?
4,3.
4,
3,4.
3,4, right? 3,4. So basically this one was executed. This was deemed as true since the output of this expression is also 4. Then it will evaluate this and figure out that this is false. So j will have a value of 4 and I will have a value of 3.
Sir?
Yeah.
So, but if we apply operator precedence in this, like the operator precedence goes for the brackets are executed first and the logical AND comes after. So why isn't that precedence followed in this expression?
That precedence is being followed. But I think the compiler is smart here. So once it sees that this is already false, it doesn't even need to like evaluate this, right?
So is this function compiler dependent or is this true for all compilers?
I think it is true for all in C. Yeah.
Okay.
So let us also try doing OR.
Sir, if we use in the if condition I equal to 3, and any operator j equal to 4, it will run or not?
Any operator. So we have only
Means
studied.
and any operator logical of and or it will work or not. Only I want.
Yeah, that is what we are going to talk about next. So we saw that in the case of AND, since it was already false, it did not evaluate the second part.
Sir, if you place I not equal to 3, then place of I equal to 3 and j equal to 4. Only equal sign.
Okay.
Yeah. Yes, this will run or not.
What do you think?
It will print inside if.
Yeah, can someone tell me what will happen in this case?
Sir, it will print both the statements.
Okay, and what will be the value of I and j?
3 and 4.
3 and 4.
3 and 4, right? So since in this case there is no short circuiting, right? Since this is evaluating to true, so it has to evaluate this. So, right? But if I change it to 0, what will happen?
It will not. It will. So, but it is showing the error in my programming.
Yeah, that is a different concern. We can, yeah, like that you can ask in Piazza. I think it can be some environment issue. But in this case, yeah, like if I print I equals 0, then again it will not evaluate this one. Since it already knows this is false, I don't need to evaluate this. So the output will be 0 and. So if I run this, the output is 0 and 4. Cool. So let's move on. So if we use OR instead of AND.
Sir?
Yeah.
Sir, if we use I is equal to 4, then it will run or not?
What do you think?
Sir, because this is an assigning function, so it will just assign the I to be 4 and j is equal to 4.
Okay.
And then it will print this inside F.
Okay.
Yes, sir.
Yeah, that is correct. Yep. Cool. That is exactly correct. So let's go back to
Sir,
this.
but why in case of 0 it is not working?
Yeah, so for 0, like since this is false, right? So what we had was this. In case of 0, this is evaluating to 0, right? So this is already false. And we know false and anything is false. False and true is also false, and false and false is also false. So basically,
But sir, it is an assigning function, no? Like equal to 0. It is not equal to 0.
yeah, so we will have to go back to the equality.c. In this, did you understand what we talked about here? So basically, we first assign 0 to I and then evaluate it as if 0, right?
Okay, sir. 0 means false and any non-zero is true. Yes, sir.
Right.
Got
Okay.
it.
Cool. So we will move on to the original program, which was this. And if I ran this, I was getting I and j is 3 and 3. Okay, so let's move to OR operator. So now what will happen? So this is basically false, but we cannot short circuit on false in OR operator because false or true is true, but false or false is false. So we need to see what is in the second one to be able to conclude what should be the output, right? So it will have to evaluate the second operator as well. And since this is 4, so this is true. So it will go inside if, and the value of I and j will be 3 and 4. So let's run this. This is 3 and 4. But now if I change it to I equal to 3, So what will happen in this case is this first one is now evaluating to true, right? Since I is 3, I equal to 3 is 3, is true, right? So, but we know that for true, as soon as you see true, you don't need to evaluate the second portion, because true is true and true or false is also true. So you can short the second portion. You don't care about the second portion. So in this case, like again, you can short circuit j equals 4. So it should print 3. So as expected, it went inside if, because I equal to 3 was true, and then it printed 3 and 3.
Sir, sir, in case of short circuiting, can we say that the operator precedence is not followed for logical and relational operators?
I don't see why you would conclude that, because it is going from left to right, right? That is also part of the precedence. So
like a relational operator has a higher precedence than logical short circuit or a short circuit time. So first the relational operators must be evaluated. So in that case, like if we replace j equal 4 with j double equals 4, then it, according to precedence, it should be evaluated.
And yeah, so short circuiting is special, I guess, that way, because we are going from left to right. So it's not because it is assignment here. Whatever is here will be skipped. As soon as you can see that there is a true, whatever is the next situation, next condition will be skipped. And you can have a whole bunch of them here, right? You can say 1 or 0 or whatever, right? You can have like lot of conditions. All of them will be skipped as soon as you saw a true. Cool. So I hope this is clear. So we can move to the
Sir?
next. Yeah.
Sir, why is it printing both the statement, like the if inside if is also printing and also the ith value and jth value?
Yeah. So why do you think? Yeah. Why do you think this will be printed?
Sir, because if any one of it is true, then the condition is satisfied and it will print this.
Okay. And is any of them true?
And yes, sir, the I is equal to 3.
Both of them are true actually. So I equal to 3 is true and j equal to 4 is also true.
Yes, sir.
Okay. So you answered your own question. And why do you think this is printed?
Yes, sir. This said okay. There is not an else condition. So
Yeah.
it will obviously print.
Yep.
Okay.
Okay. Awesome.
So 3 will be the answer.
In this case, 3, 3 will be the answer. Yeah. Okay, but if yeah, 3, 3 will be the answer.
Sir, why 3, 3 means it does not check the second condition, j is equal to 4, means it just check the first condition since it is true.
Yeah. So remember for or, like if the first one is true, then the whole thing becomes true. So true or false is true, and true or true is also true. So you don't really care what is in here. As soon as you saw a true, you can conclude that the whole thing is true. So that's why the second condition can be skipped. Okay, so let's move on to the nested ifs part. Um, let me see if I have an example here. Yeah.
Sir,
Mm-hmm.
what is the command to run the program just by saving it? Means once we save it will compile and run automatically. I think you have done something.
Yeah. So let me, okay, wait, let me stop sharing my screen and share it again. Let's share the screen. Okay. And then the key thing. Can you see this? Okay. I'm typing.
Yes, sir.
Okay. So yeah, like in Vim, there is
The voice is breaking. There's a noise.
there is lot of okay. Thank you. Yeah. So as I was saying, yeah, like in Vim, for saving it is colon and then W, right? So this is going to write the file. So W is for writing the file. For running a command, it is colon and then exclamation mark. So I can say gcc nested.c. So this will run this command. And then it ran it and says press enter to continue. So I enter, I come back to Vim. Then I say /a.out, right? And this will basically run the command. So to avoid all this, I can, there are couple, yeah.
So your screen is not visible. Like it's not shared.
Hello.
Yes, sir. Your screen is not shared.
My screen
It is
No, sir,
So
it's okay.
so it is
it's
shared.
visible.
Can I have to rejoin?
Yeah, so as I was saying, like you can run commands through colon / right, colon exclamation mark and /a.out, and you can run a few commands. So what we basically want to do is I want to run both of them together. So nested.c, and after that I want to say a.out. So you can either there are a couple of options. So you can say run, let's say, so now this is called a shell script. So you can create a shell script that says gcc nested.c and a.out. So I'm just saving all the commands that I want to run in a shell script, and I'm saving it. And if I ls-lh, it is showing me run.sh is created, but it doesn't have execute permission. So I'll give it a execute permission. And now if I run it, it will basically run the program. So now if I go to nested.c, and here I can just say run.sh, it will compile it and then run it. So every time I make any change, I can just save it and then do run.sh. Okay, so let's come back to our agenda item, which is basically comparing logical operators with nesting. So do you think these programs are equivalent? Basically, this if is basically 1 is equivalent to 2. Right? So the reason they are equivalent. Hello, can you hear me? No one is saying anything.
Yes,
We can, sir.
Okay, cool. Yeah, so the reason they are equivalent is it will come into this printf. Hello. Yeah, it will come inside this printf if both A and B were true, right? Only then it will come inside this printf. Similarly, in this case, it will come to this printf if A was true, and then if B was also true, only then it will come to this printf, right? So we can, for example, if we change this B to false, then it will not print either of these things, and we can convince ourselves by running the files. So
both of these are same.
Yeah, so both of these programs are equivalent, right? Because to come to this printf, you need A to be true, and then you also need B to be true. And
So
similarly,
is there any difference between the efficiencies of the two constructs?
no, like in older cases it might have been, but these days like compilers are very, very smart. So they might convert the same program. They might convert this program into that program. Yeah. So we can try the whole truth table if you like, but you will see that basically they perform the same. Like either both of them are printed or neither of them are printed, right? Cool. So, okay, I hope this is clear. So let's try this OR. Okay, can someone tell me what is the equivalent program of this? If
and else, or else if.
If and then?
Else if.
Else if.
Simply if, I think. If A, no.
Two separate ifs.
Two separate ifs. Else if else. Lot of options. This is interesting.
So there won't be any nesting here, I guess. Only if and then else if would be used.
Okay, yeah. So let's try with two different ifs first.
So, but then if both A and B are true, then it will print it twice, right?
Okay, awesome. Yeah, you are ahead of the story, so that is great. So basically,
Sir, we can use the exit command. If first if is true, then we can write exit command, so it will print only once and exit.
okay. So this is okay. I'll write that down as well. So the third option is you are saying we can just return or exit or something. Okay. So we will come to third later. So 1 and 2 are equivalent, right? So, and let's try a few cases and convince ourselves. So currently A is true and B is false. So what will happen is this whole thing will become true and it will print first if. In this case, since A is true, it will print the second if, and it will just completely skip else since A is already true, right? So let's run this. Let me actually comment this out. So yeah, first if is printed and second if is also printed. If I change both of them to true, then what will happen is, again, this whole thing is true, so this will be printed. Since A is true, this will be printed, and this entire else will be skipped since A is already true. So if we run this, again, we are getting both. If we change to false and false, now what will happen is this whole thing becomes false. So this printf is not printed. This first is not printed. Since this is false, this is not printed. This is false, this is not printed, and we move on.
Sir?
So yeah.
So in this construct, the short circuiting is also taken into account for the OR operator.
Yep.
But for the AND operator, the short circuiting isn't taken into consideration.
Yeah, that is a very good observation. Yeah, that is actually quite nice observation. Yeah. Yeah, that is a very good observation. I did not realize it. So thanks for pointing it out. So it looks like the one I presented was not correct. So we will have to redo how it will look like for AND. Yeah, so we will come back to this. So this is interesting. Yeah, thanks for pointing it out. Yeah, we'll come back to that. So let's focus on these. So yeah, I hope you're convinced that 1 and 2 are equivalent, and let's go to 3. So I have a statement, I have an assertion that 3 is actually not equivalent to 1. So can someone give me a reason why? So basically, anytime you're writing 1, you cannot just replace it with 3. Your code behavior might change, is the argument I'm making. So can someone give me an example where 1 may not be equivalent to 3?
We can have more lines of code after the if statement.
Yes.
We can just exit the program.
Exactly. So if I had, let's say, printf hello after all of these, then if I had, yeah, A is, let's say A is true and B is false. So what will happen in this case is, let me just to separate them out. So what happened? Oh, Mr. Slashing. Yeah, so in this case, first if is printed and first hello is printed. Second if is printed, second hello is printed. But once third if is printed, since there was a return 0, third hello is actually not printed. So this program is not equivalent to the first program. Because of this return 0. Cool. So let's move to the other comment, which is a very interesting comment, that how should we make a equivalent program with the short circuiting. So let's try it. So my original program was I think like this. So basically we had a logical expression and then we had a nested if. So this works fine for this case. What happened? This works fine for this case. Yeah, but the comment is basically it is not doing short circuiting. So in this case, like since A is true, it will completely skip B. But in this case, if A is true, then it will still evaluate B. So it is not doing short circuiting. So this is actually not equivalent to the first one.
So with and in the first case also it will not be short circuit. No, it's and. So if A was false, then it would change.
Yeah. Sorry. Yeah, you are right. So yeah, you are right. I misspoke. Yeah. So if A is false, sorry, I'm getting very confused now. So
I both will short circuit.
This is equivalent then, right? So true. So when you see a true, then you still have to evaluate the second one, and as soon as you see false, you don't have to evaluate the second one. So yeah, this is equivalent. So this is not.
Sorry, sir, I didn't see that. Sorry.
No, that's fine. Yeah, I was also a bit caught up there. So yeah, this is equivalent. So this is fine. Cool. But yeah, good discussion. I hope this is clear now. Like short circuiting should be clear, and this nesting and different operators should be clear. Any questions on this so far?
Sir, why in the third case it will not printing the last word, third hello?
Yeah, so for that it is actually it's the behavior of return, like which you have not studied yet. You will study return more properly when you study functions. Like main is like a function, but basically what return does is it completely exits the entire function. So in this case, if I put a return 0, all of this is not executed. The program just ends right here. So if I run this, it did not.
Then we can use break statement.
Okay, that's another option. Let's try that out. Yeah, so break only works in loop or switch statement. You cannot use break in a if. So there is nothing to break out of. Yeah, break does not work in if. So you have to use else if, which then turns it into the second case. Cool. Let's move on. So the last thing on our agenda is switch case. So let's go and create a new file called switch.c and copy some stuff from the big file here. Okay. So this is our program. So basically this defines an integer I with a value of 3, and then it is putting this I in switch, and it is saying that if it is case 4, then print case 4. If it is case 3, then print case 3. If it is default, then just print default, and then it exits. So if I run this, it will, what will it print?
Case 3 again and again will not terminate.
Again. Okay, so it printed it only once and then it terminated actually. So switch is actually not a looping construct. So this is not a loop, unlike while and for loop you may have been introduced to. But yeah, you will learn it more detailed in next week. But switch is not a looping construct. So switch is actually similar to your if else constructs. So an equivalent program to this is if I is equal to 4, then print this. So equal to 3, then print this, else yeah, so this whole switch thing is actually equivalent to this if else here. So basically it is first checking if I is 4 and then printing it. Then it is checking if I is 3, then printing case 3. Otherwise it is printing default. So this program is equivalent to this other program. As you can see, there is no looping involved. So if I run this, it prints case 3 twice. If I change it to, let's say, 5, it should print default twice, right? So I hope this is clear. Cool. Yeah, so switch is just, I think, just a neat, cleaner way of writing the same construct. So here, imagine if you had like hundreds of different cases, as often happens in like production programs when you are uh, writing like anything like compiler or whatnot. So you have like lots of cases. So switch is just a simpler way of writing the same if else nested, like a if else ladder, basically. So this is actually called a if else ladder, and this is called switch case. Cool. Yeah, that is all I had. Anything else you want to ask?
Yes, sir. I have one more doubt that when I am using %d in printf for power function, it's showing me incorrect results. But when I'm using %f, it's showing me correct results. How? Why?
Yeah, so one thing actually you should start doing is search for pow c, right? Let's search for it. So what does this say? Power function computes the power of a number. So again, you have not yet learned functions. You will learn functions in a bit. But basically what pow returns is a double, right? So you give it two doubles and it returns a double. So you cannot print a double with %d, right? Because with %d it is evaluating it as a integer, a decimal integer. And internally, like these types are stored in different ways. So that's why it is giving you the wrong output. But if you print it like %.1lf, so then you should see the right output.
Okay.
Excuse me, sir.
Yeah.
Sir, I had a doubt regarding the question in the assignments. So there were some questions where it was told to take an integer and find the factorial, for example. So if I want to make my program more foolproof like type, so I have introduced my variable type as float and restricted that only integers should be taken, and other like decimals if will be inputted, then it will show invalid input. But how will we restrict if an user gives random inputs like characters, he will put letters or symbols, then how can we restrict that there also we will print invalid input? How can we do that?
Yeah, so I think that is a very good question, and that should be covered. So in that case, what you have to do is you don't want to depend on scanf, right? So what you have to do is you let them input strings, and then you try to parse the string into integer or float and do your custom checking there. So that is more involved than what you have learned right now. So I think when you are taught arrays, then you will learn strings, and that would be the right time to like learn that question, learn the answer to that question. So let me see when strings will be taught. It doesn't say here. Yeah, like in a couple of weeks, you will be taught arrays. So that is a good time to learn that question.
And sir, in the assignment part, there were questions where it was instructed in the question to take integers, but for practice only, I have taken it as float type variables and then restricted my output to integers only. Then will it be correct, or will I have to take only integers as stated?
Yeah, I think ask this in the lab. Like lab is more suited for this kind of query.
Okay, so thank you.
Okay, since we have 15 minutes, I think I can teach you another thing. If
Sir,
yeah.
Say if I apply a while loop, then after I cannot print anything else except for what is in the loop. Printf.
You can. Wait, are you you learned while loop already?
Yes, sir, in the last class.
Oh, okay.
Right.
Okay, interesting. Let's try it.
I also have the same question, sir.
Okay. Okay, so this is a basic while loop, right? So we start with the value of 0. Then we are saying keep doing whatever is in here until I is less than 5. So what we do is increment I by 1 and then print the value of I. So if I run this, then it shows I is 1, 2, 3, 4, and 5. Right, so now your question is I cannot print anything outside while, and my answer is you can. So if I just print something here, even if I run it, then it prints outside while. So, but what you might be doing, I'm just guessing here, but what you might be doing wrong is putting an infinite loop. So in case of infinite loop, it will never come out of the loop, right? So so if I run an infinite loop, it is always inside the loop. So it never comes out of the loop. So that's why I have to press Control C to stop the program entirely. So in this case, like outside while is never printed because it is never coming out of the loop. But in our original program, since it will come out of the loop when I becomes 5, that's why it will print what is outside the loop. So in this case, as soon as I becomes 5, it will come out of the loop. So when I run this, it prints I 5 times and then comes outside the loop.
Sir, what does the return signify here then?
Yeah, don't worry about return. So let's learn the functions first. Then, so return is tied to the function here. So this int main is a function. Return is tied to the function. So once you learn function, then you will understand what return means.
Sir, even if I don't write return in my function, it still works.
Yeah, so that is, I think you will have a void main, I guess.
No, sir, int main.
Okay, interesting. Let's try.
I'm using Xcode.
Okay, it works. So yeah, like sometimes compiler might give warning Sometimes it works, so it depends. Yeah.
Sir,
Mm-hmm.
so in the prime number question of assignment, I have doing this thing and I'm not getting for answer like 2 and 3.
What is the question?
Like identify is a prime number or not.
Okay. And
So,
how are you solving the question?
sir, at first I write, I include studio.h, math.h, the libraries and int main, and then I input and scanf that input with %d, and I initialize with I is equal to 2 with a while loop, like in the bracket I is less than square root of that input, and then with middle bracket in this I wrote if in the bracket of input modulus I not equal to 0, then printf is a prime number, else printf not a prime number, and at last I wrote I plus plus semicolon and the brackets I closed.
Okay. What is the error?
Sir, I'm not getting answer for 2 and 3. Like when I gave input 2 or I gave input 3, it doesn't show anything.
Okay. Yeah, you can ask it in Piazza. Like it seems your approach looks correct to me. But if you put your screenshot in Piazza, we'll be able to better help your query.
Okay, sir. Sir, one more question. Like in this question, do we need to rectify for the decimal numbers? Like if we enter a decimal number, then it should show an error. But if we write in %d format, it will like if we write 5.22, then it will just show like it is a prime number because it scanned it to be 5.
Yeah, I don't think you need to worry about that right now. Assume people will put like 5 or 10. They will not put 5.22.
Okay, so I don't need to rectify this thing.
Yeah.
Okay, sir.
Sir, in a question, I was storing the value of pi in a double variable, and like it was a long decimal, around 8 places. But when I was printing it, all the places were not printing. It was rounding it off to 6 decimal place. So, but I was storing in it a double variable. So, sir, how to print all like without getting it rounded off?
That is a good question. Let's try it. So you are saying hash include stdio.
Sir?
Yeah.
Sir, in infinite loops, so like till what extent will the loop will execute? So it's not possible that it will go infinitely. So like
It will go infinitely until your laptop is up.
so like RAM is being full, right?
No, it's not using the RAM. It's just driving your CPU.
Okay.
Yeah. So it like you will start noticing if you have too many infinite loops running, then your system can actually become irresponsive. Uh, so there was actually a virus called this like fork bomb. So what it does is it basically keeps creating new processes, and each of these processes is infinite loops. So they will your basically the whole system is slowing down, and ultimately it will crash.
Yeah, okay.
So I wouldn't recommend trying it on your machine. But yeah, basically for running it, you are wasting the CPU over and over. Okay, so Okay, so is this what you did? Like, what did you
Sir, I wrote %lf. I tried with f and it was not done, so I tried with lf.
and then 8 characters?
8 or 10, yes, sir.
Okay, it only prints till 6. Yeah, I don't have an answer to this right now. I'll have to, I think it might have something to do with the default behavior of LF. So let's try. Yeah, like I think by default it is printing 6. But if I said 0.12 LF, I'm asking it to print 12 characters, 12 digits after the decimal. So now it should be printing 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah.
Thank you, sir.
Yeah, actually, let's try something crazy. I have not tried it. Let's see what happens. So if I put like very big value, what happens? Let's just try it. I doubt it will work, but we'll see. So this is 25 to, yeah. So I'm asking it to print 1000 digits. Yeah, so after some point it went to 0, 0, 0, right? So this is the precision problem of your computer. I think you learn it in a architecture course in more detail, like how decimal points are stored in your computer. But yeah, like for our purpose, we don't worry about it right now. But yeah, it's interesting. Like when you do some numerical computation with your with the computer, it sometimes give like a wrong output because of this. And I think some US missile was misfired because of this. It's a numerical computation. So actually there's a separate course for learning how to do numerical computation when your digits can be inaccurate. So you can read about this, like there was a missile failure in 1991 because of this problem. So this is very real. Cool. So we are out of time. Thanks very much. I hope some of this was useful. Some of this was entertaining. So let me know like when if you want the class, if possible, if there is some questions I can answer. That way, I hope it's more useful. Cool. I'll share the recording. And yeah, thanks everyone.